The 2D flow with velocity v is equal to x plus 2y plus 5I plus 4 minus yj is. Here the options are compressible and irrotational, compressible and not irrotational, incompressible and irrotational, incompressible and not irrotational. So here in the given equation or given flow, given velocity of the flow, v is equal to x plus 2y plus 5I plus 4 minus yj. Here the first term x plus 2y plus 5 represents the velocity of the flow in the x direction, that is u. It is equal to x plus 2y plus 5. And the second term 4 minus y represents the velocity of the flow in the y direction. So it is represented by v, that is v is equal to 4 minus y. Now differentiate u with respect to x as well as with respect to y, so that here dou u by dou x is equal to 1 and dou u by dou y is equal to 2. And also in the same way differentiate with v with x as well as y, so dou u by dou x is equal to 0 and here dou u by dou x is equal to minus 1. To check the whether it is compressible or incompressible, we will have to follow the, we will have to check with the continuity equation, that is dou u by dou x plus dou u by dou y. So here dou u plus dou y dou u by dou x plus dou u by dou y is equal to 1 minus 1 is equal to 0. That means it is an incompressible flow and it is a possible flow. And coming to the whether it is irrotational component or not irrotational, we will have to calculate the rotational component, that is omega z is equal to half dou v by dou x minus dou u by dou y. So here dou u by dou x is 0 and dou u by dou y is equal to minus 2, so it is equal to minus 1 and it is not equal to 0, so that it is not irrotational component. So in the option, the right option is C. It is D. D is the right answer. A Pelton wheel turbine develops 12 megawatt power under a head of 900 meter. If two jets of same capacity are used, what is the discharge through the each jet under overall efficiency of 85%? Here, power developed by the Pelton wheel is given by rho QGH into the overall efficiency of the turbine. So here rho Q is nothing but the specific weight of the water, that is 9810, and Q will have to find out, that is the discharge of the water, and head of the water is given by 300 meters, so 900 meter, and the efficiency is equal to 85%. So the total power developed by the turbine is given by 12 megawatts, that is 12 into 10 power 6 watts. So from this equation we can find out the total discharge, that is equal to 1.6 meter cube per second. But here the question is, what is the discharge through each jet? Here there are two jets are used, so the discharge through each jet is equal to Q by 2, so that let us say Q1 equal to Q by 2, which is equal to 1.6 by 2, because both jets having the same capacity, so that it is 0.8 meter cube per second from each jet. So in the option, the right option is C. What is the ideal cycle efficiency of the diesel engine having a cylinder with bore 250 mm, stroke 350 mm and a clearance volume of 1500 cc with fuel cutoffs occurring at 5% of the stroke? Assume adiabatic index as 1.4 for the air, and here we'll have to find out the ideal efficiency of the diesel cycle, and diesel cycle is given by so here 1 to 2 is the compression process, 2 to 3 is heat addition, 3 to 4 is expansion, and 4 to 1 is heat rejection process. So here in the given data, cylinder having a bore of 250 mm and a stroke of 350 mm. Stroke is nothing but V1 minus V2 is called as 3 stroke and is equal to 350 mm, and a clearance volume of 1500 cc. Clearance volume is nothing but it is equal to V2, and fuel cutoff occurring at 5% of stroke, that is V3 minus V2 is equal to 5% of the stroke, that is 0.05 into V1 minus V2. Okay, here the swept volume is given by R, V1 minus V2 is given by pi by 4 d square L. Let us say L is the length of the stroke. So here pi by 4 d square is 250 square into 350. So which gives a value of 17180.6 cc in terms of cubic centimeters. This is the value of swept volume. And we know that clearance volume Vc is equal to 1500 cc. Now the compression ratio R is equal to 1 plus Vs by Vc. So it is equal to 1 plus 17180 by 1500, which gives a value of 12.45. So this is the compression ratio, and in generally thermal efficiency of diesel cycle is given by 1 minus 1 by R power of gamma minus 1 into RC power of gamma minus 1 by R into RC minus 1, where R is the compression ratio and R suffix C is the cutoff ratio. Here we will have to find out the cutoff ratio. Cutoff ratio is nothing but RC is equal to V3 by V2. This is called cutoff ratio, and regarding this V3 and V2 we have the known information is V3 minus V2 is equal to 0.05 times V1 minus V2, that is 0.05 times Vs. So here V3 minus V2 is nothing but Vc, which is equal to 0.05 times Vs. But we know that Vs by Vc is equal to 11.45, so that here V3 is equal to 0.05 into 11.45 into Vc plus Vc. So from this here we can have V3 by Vc ratio, so that is equal to nearly 1.5725. So that is nothing but V3 by V2 is equal, or cutoff ratio is equal to 1.5725. Now substitute these two values. Here cutoff ratio is equal to 1.5725 and compression ratio is equal to 12.45, and gamma is the adiabatic index and is given as 1.4. Now substitute all these values and we get here 59.7%. So in the option, the right option is D. A rope brake has brake wheel diameter of 600 mm and diameter of rope is 5 mm. The dead load on brake is 210 Newton and spring balance reads 30 Newton. If the engine makes 450 rpm, then the brake power developed is, here the brake power developed is equal to, is given by W minus S into pi into D plus D by 60 pi into N by 60. So this is the brake power developed by the engine when we use a rope brake. So here W is nothing but the dead load on the brake, and S is the spring balance, and capital D represents the diameter of the wheel, and small d represents diameter of the rope, and N is the engine speed. So here now substitute all these values here, where W is equal to 210 Newton and spring balance reads 30 Newtons. Here it is pi into capital D is 600 mm, that is 0.6 meters, and here it is small d 5 mm, that is 0.005 meters, and N is 450 rpm. So now it gives a value of 2565 watts or 2.5 kilowatts. So in the option, the right option is B. B is the right answer.